Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking Trifacta and AWS for sponsoring today's event. Trifacta and AWS are longtime supporters of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, today's webinar is entitled Clean Data and Accurate ML Models, and that'll be presented by Trifacta and AWS. But before we begin, I'd like to briefly review the format for today's webinar. Today's event will be an hour long. We have two presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and today's event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. So I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Vijay Balasubramaniam with Trifacta and Chris Screenack with AWS. Now, Vijay is a Senior Partner Solutions Architect at Trifacta and has over 15 years of experience helping large organizations manage their data sets and produce insights. He leverages his extensive experience in data technologies, consulting, and banking to deliver world-class solutions. Now, Vijay holds an MBA in MIS and Finance from the Carlson School of Management at the University of Minnesota. Chris is a Partner Solutions Architect and Global ML Segment Lead for AWS. Chris started his career as a quantitative strategist at Goldman Sachs, had tenure as an AI engineer at AT&T, and as a computer vision architect at GoPro. He's founded and sold two Silicon Valley startups in finance and network monitoring, ClearStation and SiteRock. As the technical lead for horizontal support of AI and ML, he's the first line of support for AWS partners looking to develop or expand AWS-based solutions. So Vijay, Chris, hey, thank you for being with us today. We're looking forward to your presentation. Now, predictive analytics can provide your organization with data insights and differentiation to rise above the competition. However, machine learning outcomes are only as good as the data they're built on, and getting the data ready for accurate modeling is time-consuming, cumbersome, and a waste of data professional skills to be polishing the materials they rely on when they should be focusing on the work that matters, creating accurate predictions that improve products, services, and organizational efficiency. So in today's Data Science Central webinar, we'll see how the data preparation process can be streamlined to produce an accurate model for Amazon SageMaker. Guest speaker Chris Screenack, Machine Learning Segment Lead from Amazon Web Services Partner Network, will provide deep insights. And during today's webinar, you'll learn the modern, scalable, and agile cloud data pipeline for analytics and ML applications, what it takes to deliver accurate models leveraging Amazon SageMaker, typical data flaws and how to remediate them with Trifacta data preparation solutions, and we'll have an end-to-end demo from data acquisition, cleansing, to feature engineering and modeling with Trifacta and Amazon SageMaker. So Vijay, with that, I'm going to turn it over to you. You can begin whenever you're ready to go.
Okay, thank you, Bill. 80% of data science is really about cleaning the data, which is, although a very boring and time-consuming task, is a very important one. And that's what is required in order to get value out of an AI ML data pipeline. So all of the value that is derived from such a pipeline is the far right in the action box you see here. But there is a real of the time to benefit ratio where all of the time goes into training your pipeline and operationalizing. So that's the basic fundamental problem that Trifacta and AWS are trying to solve, is to try to make this whole pipeline a lot more efficient and be able to add value in the process. So what I'll be going through today is I'll be taking you to a trifacta demo. This is going to be in the context of an end-to-end demo that covers both trifacta and AWS SageMaker. But before that, I wanted to just cover some fundamental concepts in terms of the architecture. So trifacta implements a data pipeline by basically integrating well into the AWS cloud architecture. So it includes tools such as Amazon Glue to catalog the data, Amazon S3 to store the data, to essentially act as a data lake, as well as Redshift. And then you have Trifacta Wrangler Enterprise Server here that typically runs on an Amazon EC2 instance. It leverages both Trifacta's own Photon engine as well as EMR for processing. And then the resulting data is put back into S3 or Redshift. And then from that point, you can use tools such as SageMaker to then perform machine learning on that data, or use tools like Amazon QuickSight to do BI or analytic dashboards. So that's kind of the overall architecture and the end-to-end tool set that we'll be talking about today. And so actually, I'll give you a very brief introduction to some concepts, but mostly I'm going to be taking you through a demo of the tool to get first-hand insight into how the tool works. So in terms of the process itself, what is data preparation? So data preparation is made up of a set of key activities. Firstly, it's about discovering your data, which is essentially understanding your data and putting it in context to be able to extract meaningful bits of information from it. You also have to structure data to put it into the right columnar structures so that it's ready to work with. You have to go through cleaning the data, that is addressing data quality issues such as missing values, matched values. Then go through a process of enriching data, which is essentially augmenting that data with additional data sources to add more richness and value to it. Then you will go through a validate step, which is to make sure that the data is of sufficient quality to be used downstream. And the reality is actually depicted as a circle, because this can be an iterative process. So you may have to go through this iteration multiple times until you get to a stage where you are able to automate this whole process and use your data for analytics. So that's the overall data preparation work. Where Trifacta adds a lot of value is we greatly improve the efficiency of the data wrangling tool. So first of all, Trifacta has a visual UI where there is no coding needed. We also provide machine learning guidance, which essentially gives you suggestions every step of the way in order to build your transformation. And to come up with the machine learning suggestions, we actually leverage trained data from many users. And that's how we are able to give you very intelligent suggestions that end up saving you a lot of time. Now, specifically for machine learning, there are certain features that are very important. So I've listed a few of them here on the slide. So it's things like one-hot encoding, binning, feature extraction, scaling, balancing data sets. So if you have like data sets which have most of the data that do not align to the target, you can balance your data sets to address that. You can do missing value interpolation, data enrichment, data structuring, and then finally we can split data into training tests and validation sets in order to feed your machine learning algorithms. So with that, I'm now going to transition into in this demo. What we'll be looking at is we are going to be working with some satellite-based GIS data, and we are going to use this data to predict the likelihood of fire. So essentially, what we'll be doing is I'm going to be taking some data from a public website from the USDA Forest Service. And here, let's start sharing my screen. Okay, so what we'll be doing in today's demo is we'll be using a data set from the USDA Forest Service, and this is about fire detection. So we have multiple years of data of fire data that we'll be using. So what I've done is I've basically downloaded some of these files, and that's what we'll be feeding it into the Trifacta model, which will ultimately feed SageMaker. So where this data is going is it's starting from this website, it's going through Trifacta, and eventually it is going to feed Amazon SageMaker and specifically an algorithm called Deep AR forecasting. Now, this particular forecasting model is able to take time series data and it can then come up with forecasts for the future. Now, in order to do that, the data has to be in a very specific format, which is what you're seeing in this on your screen here. So Deep AR forecasting expects the data to be in JSON line format, which is something that looks like this. Either this or it has to be in Parquet format. So it has to be in one of those two formats. Now, our challenge is to take this raw information from all of these files and convert into something that is usable and in this specific format. And along the way, we also have to apply data quality checks, data enrichment, we'll be doing some filtering and all kinds of different options to enhance and prepare this data. So let's get into Trifacta itself. So what you're seeing here is the Trifacta user interface. And what I have already done ahead of time is I have brought in these various data sources, which are essentially CSV files. I have brought in from files starting from 2017 going all the way back to 2014. Of course, I could keep going and adding more years, but we just used 4 years of data for this demo. And then, so in this case, I've already done this. If I had to add data set, I can very easily do that by clicking on Add Data Set and importing my own data set. For this demo, I've already done this step ahead of time. And so the next step I will dive into is to do a union. So how do you bring multiple years of data together into a single data set? And that's where a union comes into the picture. So union can be actually accessed from the toolbar. So what I've done is I've just opened up my data set, and I'm able to browse the rows and columns of it. And if you see under my recipe, I've actually inserted a step called union, which is actually found here on the toolbar. And with that, I was able to union all the years of data together. And just to give you a preview of what that looks like, I started with my 2017 data, and I unioned 2016, 2015, and 2014 data to it. And as you can see, Trifacta automatically helps me align the data in these different files and bring it into a common structure, which is what this union output represents, right? So that was the first challenge, is to just bring in those 4 tables or however many source data tables you have into a single table that you can work with. Now, this data represents time series, and one of the things that I also have to address before I can feed this data to SageMaker is to be able to ensure that my timeline in this time series data is complete. And in order to do that, I actually have to complete the time scale that applies for the range of timeline that I'm looking at. So in order to do that, one of the first things I will do, I'm going to take this date and I'm going to format it in a very specific way. And this will become apparent as I get into my next step, which is to join this data to a lookup. So I'm going to actually add a calculated field to my data and basically say new formula. And I'm going to apply a date format. So Trifacta has a number of date formatting functions. In this case, I will take the date And as you can see through the formula, put it in MMDD format. Notice that you get a live preview the way, and then basically call this field as year, month, day. And the reason I'm doing this is in a subsequent step, I'll be joining this to another data set which expects the dates to be in this format. So now what I've done is I've created a calculated field. Now the next thing I will do is I can continue to browse my data set and just see what fields I have to work with. Now there are certain transformations I can apply to make this data easier to work with for machine learning. So for example, if I have some categorical data, such as the source field, I might want to convert it into ones and zeros or binary data. This is a process called one-hot encoding, which is typically done for machine learning to give data to machine learning models. And what this does is it basically creates for each category in my source field, it creates individual columns and it puts a 1 or a 0 where the values correspond to the row. Right? So I'm not going to add this transformation, but just wanted to show you that it exists. Another thing that might be useful is to take a continuous variable such as temperature in this case, right? And what you can do is you can do binning, and you can create essentially through the bin column transform. You can either create equal sized bins, or you can even define your own custom bin sizes, and then you can create different bins of temperature ranges, for example. And that's again a very useful feature when you're preparing data for machine learning. So in this case, I don't need to do all of this for my particular SageMaker model that I'm feeding. So I'm going to continue down, but there is one transformation that I do need to apply. So in my data set for fire detection, there is actually a field that indicates the confidence level of a particular reading, right? Now, in order for me to have a robust machine learning model, if I have data that has very low confidence index associated with it, that's not very useful. So I'm actually going to apply a filter on this data set, and I can do this visually. Notice that I get a value distribution of how the confidence is distributed, and I can basically use this to filter only those rows. Here, let me refresh my page here. So what essentially I will do is for entries that have a very low confidence score, I'm going to basically exclude them from my data set. So I can do that by going back to confidence. And if it's 30% or more, I'm going to choose the keep rows transform. And notice that this popped up as the default suggestion. So this is where Trifacta makes it very easy to work with. I can simply say keep all the rows where confidence is at least 30. Now, now that I have done a couple of basic transformations, the next thing I'm going to do is I'm going to start summarizing this data, right? So right now I have a lot of detailed data, but in order to actually prepare it into the format that SageMaker expects, it requires some summarization. So I'm going to do that actually in a new recipe, and I'm going to basically extend my union and call something called as summary. And in this summary, what I'm going to do is I'm going to essentially do a grouping operation through a pivot transformation. So essentially, it's similar to a pivot table that you would do in Excel. I can use this. I can choose this option through the pivot option on the toolbar. And what I'm going to do is essentially I'm looking to summarize the data by the timeline. So recall that we had created this year, month, day field before in the previous step. I'm going to now make this the rows of my pivot, and then I'm going to sum up what is called as the FRP. Now, the FRP refers to the fire's radiative power. So it is the index of how intense the fire is. And this is kind of the key variable that we are trying to predict in this model. So I'm going to basically choose the values as sum of FRP. I have the row labels as year, month, day. And I'm going to add this to my recipe. Notice that when I do this, the shape of my data changes quite dramatically. So it goes from this very large, column, multiple column data set into something that has just 2 columns in it, right? So now that I have summarized my data, now I need to also address scenarios where I may have missing data, and that's what we will deal with next. So I'm going to go back to my forecasting model. And what I have done is I've already created a timeline which contains every possible date in the date range that I'm interested in. So if you see the way I've built this recipe is I'm saying I start off with an infinite list of dates, and I'm only keeping those dates that fall between 2014 January 1st and 2017 December 31st. Right, and so that's the total timeline that I'm interested in, and then I've filtered my my data set or my date range to cover every single day within that date range. So the next thing I'm going to do is I'm going to take this list of dates and I'm going to do a lookup, and I'm going to I'm going to essentially combine this data with the summary that I previously put together. Right? So this is the data that is coming from my data set. I'm going to select a lookup key. The lookup key in this case is year, month, day. So as soon as I do that, what it will do is it will go ahead and read the data from my other data source, and it brought it into my view. Right? So now notice that here I immediately get a data quality bar, and looks like I have some missing values. Right, so this is exactly the kind of issue that you have to deal with before you can feed a model such as DeepR. So if I click on missing values, you can see that it gives me, it highlights those rows for me, and it also helps me. So Trifacta can help me clean up or address these missing data values. And the way I can do that is by going to the replace transform, going to missing, and what I can choose to do is I can choose to fill the missing values with the last valid value. This is, of course, one of several different options of how to replace or do missing value imputation. You can also do things like averages and modes and rolling averages and so on. In this case, I'm going to go with the fill down with the last valid value. So this is the transformation where I'm basically going to apply it to the sum FRP. I have to give it a sort order, right? So when it fills missing values, it needs to know what is the sort order. And so the sort order is based on the date range. So it's this particular field. So notice that what it immediately did is wherever it found a missing value, it basically copied down the value right above it. And that's what it's going to put into that field. So this way, I can add this to my recipe. Now, if you notice, I don't have any missing values anymore. So I've addressed those data quality issues. Now that I have a reasonably clean set of data, now I still have to somehow reshape this data to fit into the format that SageMaker expects. So it has to ultimately look like this. And I also have to split it into a training and a test data. And so the way to achieve that is to then take this columnar data set and then put it, again do a pivot on it to reshape this data. And so what I'm going to do a new step here, and this time I'm going to choose. You can also type in transformations within the window. If you see, there is a pretty long list of transformations that Trifacta offers out of the box. In this case, I know what I want, so I'm going to do a pivot table. And in this pivot table, my columns for the pivot are the range values. So this is the date range, right? So I get a column for every single field. And within the values, I'm going to do some of my fire radiative power. I'm going to add up all the fire radiative power for the individual dates. And I also have to, I'm going to specify that I want to have at least 2,000 columns to cover all of the possible dates within my date range. So now that I add this to my recipe, notice that I get a data set that looks a lot broader. So it has lots and lots of columns in my data set, which actually closely matches what I want to produce, because at the end of the day, what I'm looking to produce is a data set which is in this format. It's basically an array of hundreds or thousands of different readings for individual dates. So now that I have this, there are some additional steps that need to be done in order to actually produce some outputs. I'll quickly show you what those look like. So one of the key activities that you have to do is to take your data and then split it into a test and a training data set. So that's one activity. Another activity is also to do data enrichment. In this case, in this example, what I've done is I've actually taken this union data and I've enriched it by adding some spatial data. So I went out and grabbed some US zip code database and used a spatial join to basically bring together various geographies, convert them to zip codes, and then from the zip code you can pull out additional features that are interesting for forecasting purposes. And so you can do things like that to further enrich your data, or you could then simply filter what you have and then apply some filters to then split it into a test data set and a training data set, right? So ultimately, what all this is doing is it basically is taking the data that you prepared before and then applying certain filters. And in this case, I took the records and used that to develop a training data set out of it. So once you've done all that, then the final step is to then run a job. So what you would do is you would basically click on Run Job, and here you can specify the running environment as well as the publishing action. In this case, I want to create a JSON file. So I'm going to create train.json as a result. And once I run job, it will go. Once I click on Run Job, it will go ahead and execute this job. And what you will get at the end of that process is a file that looks like this, right? So this is the file format that SageMaker expects and to use for the deep AR forecasting model. So that more or less concludes the trifacta portion of the data preparation. So now the next step is we are going to be transitioning into the second half, which is the SageMaker. And so my co-presenter, Chris Quinak, is going to be talking about that process. So I will turn it over to Chris.
Thank you, Vijay. And I just want to say you did a brilliant job on that recipe. So that was fantastic. All right, so I'm going to start off by sort of taking a look at the big picture of machine learning services at AWS before we zoom into SageMaker. This is what we call the machine learning stack at AWS. On the top level of that stack, we have what we call our AI services. AI services cover vision, speech, language, chatbots, forecasting, recommendations, and they require no previous machine learning experience whatsoever. They are API-based, so if you've used any SaaS-based service online, you can instantly take advantage of deep learning in many of these highly applicable managed service forms. So at the bottom of the stack, so that's the top of the stack, the AI services. At the bottom, we have our compute and storage services, which are, once again, the broadest and deepest available today. We have a prescriptive approach to how we how we do machine learning. In our frameworks area, we support TensorFlow, MXNet, PyTorch, and the higher level interfaces to those deep learning frameworks such as Keras and Gluon. Also, we're not limited to developing machine learning models that execute in the cloud. In addition to the models that we create in SageMaker that run on persistent endpoints or in batch mode in the cloud, we have AWS Greengrass. We also have mobile services, in particular with Amplify. So machine learning models that are developed in the cloud at AWS may run in the cloud. They may also run on edge devices such as NVIDIA Jetson or Raspberry Pi, or on your phone. And increasingly, this is what's happening. People that are developing machine learning apps for the phone are developing, building them, deploying them in the cloud, and then moving them onto the platform for whom they are designed. Well, with this approach, we have discovered that more machine learning happens on AWS than anywhere else. There are literally tens of thousands of developers that are running machine learning on AWS today, and we've had extraordinary growth. In particular, 8 out of 10 TensorFlow workloads are running on AWS. So we take a unique approach in this space. First of all, we are uniquely customer-focused. Some organizations are product-focused, and they'll say, build like we build. Others are competitor-focused, and they say, follow fast, and that will be successful. The reality is, both of those approaches can work, but at Amazon, we are unusually customer-focused. We start with the customer need and then work backwards from there. 90% of the AWS roadmap is built directly from customer feedback. The other 10% is where customers don't quite know what to ask for, so we have to read between the lines on their approach. Our approach to innovation is fundamentally different. Instead of large, expensive, and frequently disconnected R&D teams in an ivory tower, our scientists are embedded with our product and engineering teams. They work on advancing the state of the art, but do so in close proximity to our customers, working backwards from their needs closely aligned to our engineering teams. We invent and simplify on behalf of our customers in a way that very few organizations do. It's this unique approach that fuels our pace of research. Third, customer choice and flexibility is incredibly important in this space. We like to joke that machine learning is the primordial soup of the moment. Take frameworks, for example. Some are focused on pushing customers to just one framework, but we have a different perspective. It's way too early to be locked into any one framework, particularly when they all have different strengths and developers have different preferences. We're not trying to tell you that you should try to solve all your machine learning and deep learning problems with one framework. If you study the history of machine learning, the one constant is change. As a result, we support as first-class citizens all the popular frameworks and interfaces and facilitate choice and customer flexibility. It is very early days for machine learning, but the capabilities, the technology, and customer needs are evolving rapidly. Since December of 2017, we have launched over 150 major new machine learning features and services. No other provider has done more than half as many. So developers wake up and have new materials and capabilities at their fingertips virtually every day. At Amazon, security is always job one, and increasingly privacy. The same deep security mechanisms you find throughout the AWS services are integrated into all of our machine learning services, extending from the cloud to the edge with AWS Greengrass. So there are 3 areas where we are seeking to constantly improve for our machine learning developers, and they are cost, data, and that's preparation of data, which we're covering today, also aggregation and reducing the complexity for accessing that data in a data lake, and then finally, ease of use. So with Amazon SageMaker, we've taken this approach where we want to make it as easy as possible for you to get to your data, to look at it and begin experimenting with different algorithms to get to production results as quickly as possible. To do this, we start by providing pre-built Jupyter notebooks for common problems. In many cases, all you need to do after you've done the data prep, Vijay, so well just described, you choose your algorithm. We will then, if you choose one of our built-in algorithms, which we're going to cover one today called DeepAR, we will automatically optimize that algorithm for you. We also will set up the training environment for you, which has been a particular blocker for data scientists and developers in the space. When you use our built-in algorithms, it is literally one click or one API command to deploy training with shared memory models between GPUs on a single machine or up to thousands of clustered machines. The optimization will take place using some machine learning itself in a Bayesian approach, as opposed to what has happened in the past, which is spray and pray or trial and error. So it is really an essential aspect of machine learning deployment. Now, when it comes to deployment, once again, it is one click or one API command, which we'll see in the SageMaker notebook in just a few moments. Finally, last but not least, it's important to be able to deploy at scale globally. This also is facilitated through SageMaker. So how do we do all this? Well, it's important to look at SageMaker not as a single service, but really as a tightly integrated integration of four components. Amazingly, each of these components will stand on its own and can be used independent of the others. So, for example, if you want to work with sample data on your laptop to develop models, you can do that. When you're ready to train for production on the full data set in S3, you transfer your model to a Docker image to the cloud, and then you get the full power of AWS infrastructure. Alternatively, if you just want a Jupyter notebook in the cloud or to launch from your application, SageMaker's notebook instances are designed to be launched independently as standalone apps. They can be integrated seamlessly into your commercial or enterprise environment. The built-in containers for SageMaker, such as TensorFlow, PyTorch, and MXNet, are open source, and they're available on GitHub. You can build them, add them into your code, run them locally on your machine, and customize as you need. When you're ready to upload into the cloud and train, you can simply do that. Finally, if you build and train models on premises, you can use SageMaker to just launch inference endpoints globally and at scale. If you're just getting to know SageMaker now, we recommend that you discover its features in the cloud. In other words, just as an integrated whole. As your familiarity with the system grows, feel free to integrate the individual components in a way that makes sense for your workflow. So just one more bit on this process. SageMaker is driven by a Python SDK. We call it the SageMaker SDK, which you can also find on GitHub. This SDK helps you orchestrate the machine learning process. So you start with experimentation. You explore your data, do some pre-processing, create some visualizations, maybe some basic feature engineering, trying to figure out what that data is and how you can start work on it. To make that simple, we provide fully managed EC2 instances called notebook instances that come with the pre-installed SageMaker notebooks. We also provide more than 100 sample notebooks that we've written, and that includes all the deep learning libraries that you need. We include basic analysis tools such as Pandas and scikit-learn, and underneath that we have NVIDIA drivers that are pre-installed with a CUDA environment. So if you need to use GPU processing in the notebook, it is essentially an off-the-shelf development environment for machine learning developers and data scientists. Now, these are real Linux instances with shell access. You can bring anything to Linux environment that you would like to use, such as TensorBoard or code you've already written in-house. You can run these instances cheaply. As we mentioned, we're always working to reduce costs. If you're just getting started, we even have a free tier. As your demands grow, you can fire up the powerful P3 instances, but hang on before you do. we train models in SageMaker in separate instances from the notebooks to save you money. Building and training occurs on completely separate instances. You spend a lot of time with simple editing in a notebook. There's no reason to pay the big bucks just to do that. In a nutshell, it's everything you need to build models at scale at the lowest possible cost. So before you spend any time writing some code, take a look at our built-in algorithms. These are powerful machine learning algorithms, and they're the exact algorithms that are used by Amazon data scientists and engineers. They're ready to go. You just select one, set some parameters, point at your data in S3, and train and fit. You literally do not need to write a single line of code to build machine learning models on AWS. Today we have 17 algorithms ranging from typical problems such as linear regression, classification, and clustering, all the way to the advanced stuff like vision, language processing, time series analysis, anomaly detection, and more. And you can see a full list on our website or just run them yourselves with our sample notebooks. If you have your own frameworks, no problem. Build everything into a Docker container and use SageMaker to train and predict. Once you're happy and you figured out which algorithm you want to use to solve that problem, you can train literally. It's one click or one API call. So to fire up clusters on AWS, it is literally just one click, and there are 0 servers to manage on your side. SageMaker will train a model using the algorithm that you specified, and the data is in S3. Once the model is available, it's saved back to S3, and the training instances are terminated. You stop paying at that moment. You never have to overpay to do training in SageMaker. When you use SageMaker's built-in algorithms, you get hyperparameter optimization for free. Once you're happy with the accuracy of your model, you're ready to deploy. Once again, it is one click for that. And in addition to deploying persistent endpoints, we also provide batch transformations. So for example, if your model is only called once a week, once a month, or whatever, you can spin up the same Docker container you prepared for a persistent endpoint, but this time it's on demand. You can grab the data from S3, cycle predictions through your batch, and get results back on S3. Okay, so that's how SageMaker works. We wanted to present a live demo. Vijay is going to help me here because we couldn't get the screen sharing to work, regrettably. So I just uploaded onto GitHub the sample notebook that runs DeepAR on the model that Vijay had done the data prep for. So Vijay, while you're sharing your screen, I just want to talk a little bit about the algorithm we chose. DeepAR, if you're familiar with ARIMA, doing time series forecasting has had a lot of pitfalls in the past. So what is the problem that we're solving with DeepAR? Well, first of all, what we're doing is we're applying deep neural networks to a time series projection problem. The notion here is that we're employing essentially a recurrent neural network for probabilistic forecasting. And in the process, we'll be incorporating a negative binomial likelihood for count data and doing special treatment for cases where magnitudes may vary widely. So we, of course, have data set requirements, which Vijay has fulfilled. One of the benefits, though, of using DeepAR is there's a significantly reduced amount of manual feature engineering that's required to capture complex group-dependent behavior. Probabilistic forecasts in the form of Monte Carlo samples can be used to compete consistent quintile estimates for all subrange in the prediction horizon. And by learning from similar items, the method is able to provide forecasts for items with little or no history at all. So there's a lot of advantages to using deep neural networks for this kind of time series forecast. First of all, we can support many types of data, real numbers, counts, and values in intervals, automatic evaluation of model accuracy for back testing after training. You can scale data sets comprising hundreds of thousands of time series formats. We support JSON lines or Parquet format. And one that I find most useful is that it supports many missing values, including categorical and time series features. Vijay, I'll just assume you have that GitHub page up now. So we will make this available. This model was written by one of my colleagues on the team, Gordon Heinrich. And I think it's a really useful and timely model considering we're just leaving the fire period here in California. So what we're doing is we're essentially using the data set to predict fire radiative power into the future for various geographies. In cell number 1, we're just setting up our environment, just some basic stuff such as datetime, Boto 3 for the Amazon API, SageMaker, NumPy, Pandas, etc. So we set up our SageMaker session. We set up our buckets, both for our training and test data. We're also going to be writing our results out to S3. Then we set up to train our model. Now, with Deep AR, we do need to choose a frequency for our time series. Here we are choosing 1 day. One thing I didn't mention, deep learning does a lot for us using SageMaker, but your data does still need to be stationarized. So the degree to which you can stationarize your data is obviously going to improve the quality of your model. And there's a number of techniques which I won't get into for this, but I don't want to miss that important item. You still do need stationarized data. So we will use 1 day frequency for the time series. We'll have a prediction, and we will also use 30 days as our context length. In the next cell, we're setting up essentially what builds our Docker container here. It is a SageMaker estimator, and you can see here that we're specifying a C4 2x large instance type for training. In our next cell, we set our hyperparameters. As mentioned, SageMaker will do automated hyperparameter training for you, but also we have exposed our API for hyperparameter training. So in this instance, we, for example, are doing a dropout rate of 10%. We have 10 layers. Please do review the SageMaker documentation to see what other options are available for hyperparameters. We set up our data channels, and then we train. Training, when you use the fit command on estimator in this cell, will actually go off, and as mentioned, the training takes place in a completely separate instance. That was all set up with our estimator. If you scroll back up there, you see we have an instance count here of 1, but that number, I have seen literally hundreds and even thousands of instances fire up to do training. Now, there's a lot of output here as we go through the training. I'm going to ask Vijay to please scroll down to the very bottom where we have launched our endpoint and done 1 simple plot to see what our immediate predictions are. Now, what I would expect for usage for this particular model would be not to have sort of this view of the entire United States and perhaps, do an animation. That might be interesting, say, for a news article where we're, saying, hey, we have the ability to predict fire danger in the coming year or months or something like that. What I'd really expect is for infrastructure engineers, say people building renewable energy plants, doing either waste or water management, to zoom in on a particular locale and begin to do predictions in that area. So as we begin to evolve this model, we're going to add some of those features to kind of zero in to make this a pretty generic model for physical infrastructure planners in the days to come. So that's SageMaker, and that is the particular instance that we worked on for this demonstration. I'm going to give the line back to Vijay, and I believe we've got a few minutes for Q&A.
All right. Thank you, Chris. So at this point, Bill, do we have any questions?
Yes, Vijay, Chris, hey, thank you for that great presentation. Sorry about the technical difficulty. So let's get started with today's Q&A session. And I want to thank the audience for their participation. We've had a lot of questions that have come in during the presentation, so we'll do our best to get through all of them in the time remaining. And during this Q&A period, I'll leave up this picture, this slide. Hold on one second. Here it comes. With contact information for Vijay and Chris if you'd like to contact them following today's webinar. Well, Vijay, as clients contemplate getting involved with Trifacta, what are the economics involved here? How do people calculate the ROI in using Trifacta?
That's a great question. So the ROI for Trifacta really comes in terms of time saving. And if you think about data preparation as an activity, if you're doing it manually using, even using like R, Python, writing your own scripts, it tends to take a lot of time, and that time obviously has some dollars associated with it. And with Trifacta, one rule of thumb you can use is you can typically expect a 60% reduction in the amount of time it takes. And that's really the main driver for the ROI. So the way to calculate ROI is to look at how much time you're spending on those activities today and slash that by 60% and convert those into dollars. And that's what it would be.
Well, Vijay, thanks for that clarification. Our audience was clearly paying attention. They saw you replacing those missing values as part of your data prep that you demonstrated, and they're asking how you would handle NA or NAN values.
Again,
oh, go ahead. I'm sorry.
Yeah. So we do handle missing values as well as NA and NAN values. So one of the suggestions actually that pops up typically is to replace missing values with something else, and you have complete flexibility on editing that suggestion and putting in whatever value you would like to replace those missing values with. So you can certainly choose NAN as one of the values that it translates to. We are also able to handle missing or NAN values coming through the source. So sometimes we get NAN values in the source data, and we provide ways for you to handle those as well. So
thanks, Vijay. I want to add for deep AR.
Yes.
So let me just add, this is important. For the deep AR built-in algorithm at SageMaker, NAN values are acceptable. So there's no need to pre-process by creating fake values or anything. Leave NANs as NANs.
Oh, interesting. Thanks, Chris, for that clarification. Vijay, is there a way for our audience just to try Trifacta? Is there a demo or a short-term application they can use to experience Trifacta?
Sure. So on our website, we actually have a free Wrangler product, and you can access it at cloud.trifacta.com. There are some limitations to the free product. So as long as you stay within 100 megabytes of data and you're working within your own self-contained environment, you can use that environment. If you're looking for larger data sets and you want to also collaborate across your team, we have other offerings such as Wrangler Pro and Wrangler Enterprise, and those will basically those options give you basically unlimited processing power, having support for multiple users, full lifecycle operations, as well as SDK and integration with third-party tools. So a lot of options, but a good place to get started would be the free Wrangler product at cloud.trifacta.com.
Oh, thanks for that information. That'll be interesting to try. A last question. is this approach to data preparation actually replacing ETL? Is it in addition to ETL? How does this relate to our existing practices of ETL?
So it really depends on your use cases and your data needs. So there have been many situations where we have complemented ETL, and ETL still has a function to play in terms of data ingestion from a variety of different source systems. But wherever you have time to market as an important factor, that's where you should consider a data preparation tool such as Trifacta, because first of all, we rapidly shrink down the amount of time it takes. Also, we empower a business user or an analytical user or a data scientist to actually do all of the data transformation work themselves without having to rely on IT or another group to do the data wrangling. So we bring that self-service model to the people who are actually working with the data, and that's where we are a great complement to ETL.
Well, Vijay, Chris, hey, thank you for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Vijay, Chris, and the Trifacta team so they can follow up with you after today's webinar. You know, I have just a few quick announcements. If you'd please mark your calendars for December 20th, that's our next DSC webinar, which is Analyze Data Faster with an Open Source Columnar Database. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. And also remember that past webinars are available on demand at datasciencecentral.com. And if you haven't had a chance to look into these, I encourage you to check them out. They provide some very useful insight into a wide variety of topics of interest to our data science community. Well, this brings today's webinar to a close, and I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Trifacta and AWS for their sponsorship, and particularly our speakers today, Vijay, Balasubramaniam, and Chris Screenack for their insight into today's topics. So this is Bill Voorhees. I'm very pleased to have been your host for today's event. Look forward to seeing you all again on December 20th. Have a great day.